I was going to ask you before I got started.
I'll try and keep up with you.
Okay. All right. I'm Carlson. I'm with Obermiller Nelson Engineering. We're a engineering consulting firm. We have offices throughout the state of Minnesota and North Dakota. I'm a 2006 alum from Mora. I recognize a few faces here today. So it's fun to be back here. I do get back on a regular basis, seeing my parents and brother who still live outside of town in the school district. I got a degree in physics from Gustavus and Master of Science degree in mechanical engineering from the University of Colorado Boulder, and I'm a licensed professional mechanical engineer in the state. A little bit about Obermiller Nelson Engineering, or O&E as we call ourselves. We've been in business for 26 years. We have a large team of seasoned design and engineering professionals. As I said, we have multiple locations. Yeah, just a little bit more about our company, our values, and some of our experience. Last week I came down here and conducted a walkthrough of the school and documented what I saw, noted inadequacies, and tried to identify the highest priority pieces of equipment and spaces that would most highly need to be addressed if we were to invest in the school for the immediate future. So I'm going to take some time to just kind of walk you through what I saw, show you just some specific areas and photos that I documented to let you know what's down in the guts of the school. A lot of people don't get the chance to see those conditions, and they don't know what they're looking for. They don't have the experience or the expertise to identify areas of concern or deficiency. To start off, the facility maintenance staff have done a great job of keeping things going. They've managed to keep equipment running much longer past its average useful life. A lot of the HVAC equipment in the facility is original to the different additions and years of construction. It's all over the place, but the average age is 41 years old. So that's pretty significant. The boilers, which as Jeff mentioned are kind of the heart of the school, those were replaced roughly 20 years ago, and so they have a good 5 or 10 years of life left in them before you'd want them to be replaced. So that's not necessarily an immediate point of concern that I identified. They're operating well according to Kurt and Chip, and they're not necessarily something that need to, I mean, it's a big project too to do boilers. You don't want to go after that unless you really have to. So those are in good shape. Okay, starting in the basement, the fitness areas in particular is the first place I want to look at. And I'm bringing this up so folks can see in greater detail the areas that I'm talking about. The weight room and the 2 cardio exercise spaces in the office in between. Next slide. Some photos showing the existing conditions. This is a unit ventilator in the ceiling. It's the only source of heat and fresh air. This is the only sort of cooling you have in all those spaces. It's a window AC unit. The other one has been boarded up and covered up. So it's a big point of immediate need. Another space is the doors between the 2 locker rooms on the east side of the school. This is a steam cabinet unit here, and it's got a perpetual leak on the fitting right down the bottom. And one of the things I noticed when I walked around is that there are no isolation or shut-off valves on any of the heating equipment. And the only way for Kurt and his team and Chip for them to service this equipment is to shut down the boiler plant completely when students aren't here or when it's unoccupied, and have someone come in and fix that. Remarkably, inefficient, remarkably costly. And so taking the time to install shut-off valves on that would be very, very useful for the immediate future of the space. In addition to that, you'll notice that the condensate return piping goes right down to the concrete. It's probably, as long as that leak's been happening, been corroding continuously, which poses a significant concern of leaking. And the only way to get to that is to sock up the floor and just keep cutting back until you can identify that the pipe is in good enough shape to keep it in place. So converting that to hot water, maybe that might be something you want to look into.
Are there others of those units in the building besides that one?
There are other steam cabinet heaters, but none that I noticed or was aware of that are leaking. So moving up onto the main level, the second floor here, looking at the junior high wood shop. That's the only source of heating in the entire space. Easily past its service life and original to the space. This is the dust collector, which, as I understand, has had at least one fire in it. And as Jeff had mentioned, there's significant air quality issues with that system, so that would definitely want to be replaced as well for the safety of the students. Looking at the air handling unit that serves the band room space here. And then it currently does not, it's a constant volume unit, multi-zone. It doesn't have any dehumidification to it. This is the ductwork configuration and how you service it. This is, again, the only source of cooling in the entire space is a window AC unit in the teacher's classroom. So providing dehumidification would, and a variable volume unit would greatly increase the comfort in that space and provide a much better control of ventilation as well. I'm not sure if you're aware of this. Can you go back a slide, Kevin? The cafeteria is currently served by 2 different air handling units. They are independently controlled, one of which, to my understanding, barely functions at all and is very, very hard to keep going. It's really not an acceptable method of conditioning and ventilating your space. So I would recommend that you call it rezoning, would be the technical term, but you basically pull all the ductwork out and you put a new unit that serves that space, dedicated to it specifically. The other thing that does is it changes the zone or the spaces that the air handling unit number 8 serves, and that is also a unit that is well past its life and is something that's a continuous headache for Kurt to resolve and deal with. Okay, and then the boardroom and staff lounge where we are now. We poked our heads up above the ceiling here when we were here last week, and there currently is no outside air being ducted into this unit. So it used to come in through the old unit ventilators on the wall here, but that's been closed off. So all that's up there is just recirculating air and cooling it down.
And if anybody needs to know why it's been closed off, it's a lot because of functionality when it comes to being able to conduct anything.
Just because it's too loud, has other issues, comfort issues. Moving up to the 3rd floor, the fax classroom areas, these have been touched on several times, but they currently all have unit ventilators, all controlled independently of one another. There's no dehumidification whatsoever, and have a lot of service calls for heating and discomfort issues in those spaces. So putting those all in one unit would make a lot of sense for the students and teachers in those spaces. Plus, I believe there's an office space or storage room that has absolutely no ventilation here whatsoever. A couple office spaces in the middle of the third floor here. This is currently used as a teacher's office. It's probably a storage room at one point, but this is the only source of ventilation to the space. It's actually an exhaust grill. It's controlled by a wall switch, so that's very, very inadequate, and it's really hard to spend a significant amount of time in there without feeling groggy from CO2 concentrations and other things like that. And then, just went back when Jeff touched on this, but the indoor air quality issues with high CO2 levels on the fourth floor as well as on the third floor. What's the word? That would trigger the need to basically recommission the units that serve those spaces, which you bring service technicians in and they rebalance the outside air flows, they make sure all the air is in C.E.M is getting to the right level as it's supposed to be, and should help address the indoor air quality issues in those spaces. All right, just a little bit on plumbing. You guys have some really, really old pipes in this building. It's been a real chore to service them, and when you have needed to, it's often required repairing much more than you were originally expecting, because the walls of the pipe have gotten so thin that you can't adequately weld to it.
Right.
And so you have to cut it back far enough to the point where it hasn't degraded to that point, and it can be, a factor of whatever multiple you want to choose beyond the initial budget. Plus, insulation is just falling off everywhere. There's asbestos issues to deal with. Plus, a lot of your piping is encased in concrete in the floor, and so it's not serviceable. It's a good chance that you're losing a lot of water. I know that you are through your C.E.M system, losing 55,000 gallons of water in the last year in the boiler system. And you can't repair the piping that's going through right now. The recommendation to upgrade a lot of your HVAC systems and provide dehumidification for your students will likely trigger the need to increase the size of your electrical service. That probably was not accounted for when electrical transformer and service was sized for this facility, and so that will cascade all the way back probably to the main service of your school and the facility here. And most of what I'm showing you here is all original electrical equipment that's far, far beyond code allowable technology. Just a brief summary here, kind of touching on 5 major points. Upgrading the HVAC equipment as I outlined, the diagonal hatched spaces, which will likely trigger upgrading electrical service and breaker panels and whatnot down the basement. Installing isolation valves on your heating equipment so you can service them without shutting down the boiler plant. That will be a very, very positive benefit for the maintenance personnel. Converting existing controls from pneumatic to DDC. The school's pretty much a black box for Kurt. There are a few systems right now that are on DDC controls that he can access remotely and can control, but for the most part, it's wall-mounted thermostats. He has no idea. Temperatures range from 65 degrees to 79 degrees throughout the school, and that's pretty unacceptable. It's far exceeds ASHRAE's allowable limits for comfort for a school of this, well, for occupants of this type in the school. Plus, it gets it to a network that he can access remotely, So he could be over at Trailview and say he gets a call for heat or cooling, or there's some issue that comes up, he could jump on his cell phone and look at that system and be able to change settings from that point. And what we would recommend would be the same control system that was recently installed on the Trailview School and Wellness Center. Replacing as much of the domestic water supply piping as you can get your hands on, just primarily getting it up out of the concrete, but then also to mitigate any lead-based solder that's leaching into the water, and any other leakage issues that are creating moisture and mold problems and ceilings that can mitigate a lot of those problems. And then rebalancing and recommissioning your HVAC systems that have got the indoor air quality issues. So that would be the highest priority things to do in the immediate short term for this school if you're going to stay here for the immediate future. It's certainly just the tip of the iceberg, as someone has said earlier tonight. There's a lot more items that would need to be addressed after 3 to 5 year window.
Did you happen to look at sewer systems at all? I mean, we're looking at the quality of water coming in, but then the loss of water going out. One of the things that I heard being on the Buildings and Ground Committee is that the sewer lines leaving this building, the bottoms have deteriorated out to the point where they can't be cleaned anymore, they can't be serviced. Did you get a chance to know anything or can speak to that at all?
I can't directly as to what I looked at last week, but you could make the conjecture that a lot of the pipe is in similar condition and is very, very hard to service. Whether or not it warrants an immediate remedy, I'm not sure. I don't know if they're keeping track of the domestic water that's coming in and out of the school at all, but yeah, it's definitely an issue, potential issue.
I have a question. 55,000 gallons in the last year. Where do you think that went?
My guess is that it's being lost through the condensate coming back to the boiler. It's probably going into the ground, being that you're not finding any leaks around the school, in the ceiling or in the walls or something like that. Yes.
Could you talk a little bit about the interconnectedness of plumbing systems generally as an engineer and modifications to toilet facilities, infrastructure throughout the building for sinks and whatnot? In other words, if it's a very old building, the existing piping may not be up to code in terms of its volume capacity.
Oh yeah, that's very true. Plumbing code has changed since the initial construction of all the wings of this school, and so it's very possible that the current size and capacity of the plumbing piping is not large enough by today's code to handle.
So if we were to replace or to make a ADA compliant restroom, putting in a new toilet, for example, and replumbing that, we could run into not just making one room, but then having to fix all the plumbing that's connected to it, or come up to code with the plumbing that's connected.
I don't know if that would trigger the entire rest of the plumbing system to be resized.
It certainly would if we were renovating bathrooms.
Yes.
We're gonna renovate them for ADA, which means now we're gonna go ahead, we're gonna not only look at the domestic water piping and what has to come there, but also the size of the sewerage lines leaving the space. And they could say that needs to be sized for 12-inch pipe, and you have a 4-inch pipe in there. Rip that all the way out, and it wouldn't be the whole building, but it would be anything that we're touching again. It's going to go all the way back, so it's more saw cutting, other items.
And I thought of that because that's what we had to do with Trailview. When we started doing the Trailview project, that coding had changed in just 20 years to the point we had to bring in a mini excavator in the middle of that building and dig down and replace the.
And that was sort of a combination of not only adding additional capacity to that building, more students, but also the plumbing code changes from when the building was built. So you can see it come from both ends. Sure. No pun intended.
Well stated.
Any other questions?
Are we gonna speak to costs of these minimal things that is that coming or not?
Whereabouts are we on for the HVAC approximate?
Approximately, if we're just looking at HVAC ventilation piece, not the plumbing, it's in the $4 million range.
How about the electrical?
Yeah, electrical upgrade not included?
Yeah, we got more to.
You're talking
Well, it's hard,
more millions for just the electrical.
that's the hard part is once you look at one thing, it triggers another thing and another thing and another thing. And so when we're talking with the building committee, we gotta really start to look at all little aspects, and we'll try our best to have budgets to the best of our ability on those types of things.
But the 4 million you're attaching to these priorities that Cole just referenced at the end of, that you think should be
Only
done.
the HVAC,
Right.
not of the plumbing,
Not
not
the electrical.
Mm-hmm.
And there's more that come into that. We gotta tear into walls, and we gotta patch the walls. We gotta do asbestos removal before we go. There's a lot more to, when we give you a number, we gotta really work to capture all those.
This is the dilemma that a lot of districts get into is, let's say you're just going to do an HVAC project, which is pretty common. Let's get the air quality up to speed so we're not dealing with CO2, moisture, et cetera. So now you're gonna take the ceilings down, you're gonna replace the ductwork, you're gonna move everything out of the room. Are you gonna put the room back together exactly like it was if you know it doesn't function for the educational purpose? So then a lot of districts go, well, no, we should probably, if we're in the fax room doing that, should we upgrade that? Okay, now you're renovating fax, and now the code starts to say, oh, while you're in there, you're gonna now start to deal with some of your ADA issues. If you just stick to the HVAC, they might not trigger the ADA, but it's the looking at where do you stop as you start doing some of these things? What's the intent that you wanna go to? And that's really the dilemma that most districts get into is, if we're taking it all apart, are we putting it back together in a non-functional way, or is it time to address some of those issues?
And then as those costs increase, they start to get to that point of the replacement cost, and then what we could actually do with the new space versus trying to make an old space work for our students.
Good. I think it was a hard question to answer. What's the return on investment? And it threw me for a loop because when we typically talk return on investment, you're measuring an energy performance project. But if you are saying what's the return on investment for an entire building, it doesn't really work that way because you have to start looking at some different factors. You could certainly look at energy, but when you look at energy, is just replacing the windows going to be a payback if your mechanical systems aren't energy efficient, or if you don't have the right insulation in your roof or your walls? Then you can start to get into what's lost. If you're losing 55,000 gallons of water a year due to your system, what's that return on investment? And you can start moving into the subjective pieces, and there's a number of studies around student performance related to daylighting, air quality, acoustics, the number of different factors that you can have as a constant and measure and say, are student test scores higher in rooms with appropriate daylighting or without? Are they higher with appropriate ventilation or without? Then you get into things that work against that. If you're bringing more fresh air into the building, that also means you're spending more energy to come into the building to do that. So it starts to balance out the other way. And then unfortunately it gets down into the cost of the things that you hope you never have to deal with in terms of human life. When you're talking secure entrances, security issues, you can say, well, we've never had a problem before. Is one life the right cost for that? If nobody's ever been hit in front of the building. Do you wait for that to happen, or do you say that's where it is? And those are the most extreme subjective pieces that you're measuring. So I'm not sure that there's a good way to answer that return on investment question. And sitting here thinking about that going, well, there's a lot of different ways to look at it. But that's sort of the myriad of issues that you start to deal with when you're looking at these.
And as you're way out, whether you go for a referendum again, the tax impact of that versus the tax impact of a Plan B, that's where you're going, right? What's the best taxpayer value? I think I know that answer to myself, but I don't live here. We're gonna do the best we can and put the right information for your community to make those decisions. But it'll be clear tax value of each of those options. And I think that's part of that, you know, what's the best financial long-term investment, what's the best payback? I think when you look at those types of pieces of information, when we get all this pulled together, I hope it'll answer that question for, you know, for folks about that, because I think that's what, plus other things come into play on that. State helps pick up the share of something here, they don't help pick up the share of something here, and I think there's a lot that really come into play when you're really trying to figure this out.
It is, I mean, you start looking at these dollars and the amount that the local taxpayer is going to shoulder of this type of project, it's gonna be 100%. And if we can get a referendum passed, it spreads it out, and it doesn't all fall right on our local tax base.
That's correct. Yeah, and then you hear, there's things that are covered in what Cole's talking about, but there's not everything.
Mm-hmm.
There's gonna be another wave of things that are at useful life, and then the boilers are coming. Right?
Well,
And
yeah,
then-
We got 5
there's
years.
a B and a C and a
There's a
D
C.
and a D.
Yeah, there is, right?
I mean, really,
It doesn't-
if we go this way, there's a B
You
and
got
a
it,
C and a D.
You got
We're
it.
talking millions and a millions and a millions and a millions.
And there always is, no matter what you're talking about, whether you're talking about your car, your house, anything, it has a life cycle expectancy to it. So getting back again to the return on investment piece is, what's the best way to spend investment monies on maintaining what you have? And at what point do you say, what we're putting into what we have is beyond the use of what we'd be spending if we were working with something that's of a newer life cycle and a different system? And it's a very subjective thing. Every community has to decide at what point is that the level of reinvestment that you make versus a different type of investment.
Let's keep going, we got
All right.
a couple more folks to listen to.
Thank you,
real
Paul.
quick.
Thank
Think
you.
you'll find helpful.
Jackie was gonna talk to us.
Yeah.